Section 2 is going to begin to take us into that proof part of geometry. As I mentioned in the last video, this is the part that a lot of people find really scary. It's a very different way of thinking, but really all it is clearly stating why you can make a step. What was your thinking that made that a legal math move? You can't just make up things in mathematics. There are rules. So there are some pieces of information that you can use, are rules. And in geometry, our rules are really three things: definitions, theorems, and postulates. And we're going to use those to construct a logical argument, a proof, that justifies my thinking. We can't say just because in math, and we can't say duh in math. Okay, we're either going to add to both sides, we're going to divide in both sides, we're going to say they're equal to 180 because they're supplementary. We always have a reason that lets us do the next step. And that's all proofs are, is providing that reason that's already in your head. So it's just showing it on paper. So a postulate, just for definition, is one of the ways to justify our thinking, and that's a statement accepted as true. And we're not going to spend a lot of time going through which ones are postulates and which ones are theorems, but just to know if you run across that word, that it's an okay math rule to use. The one that's not on here are definitions, and that's literally what that is a definition of a math property or term. Math, we'll just say term for right now. Those are legal rules that allow you to do things. And a theorem is a statement which has been proven. As we're working through this, the distinction between a postulate and a theorem isn't going to matter. You're just going to get a bag full of tricks, a bag full of rules that let you justify your thinking. And that's the important part. So let's start with some rules you know. Let's go back to our algebra rules that we've kind of just become automatic at. So addition, property of equality. So we're really just going to always call this addition. But what does addition say? It says if I have an equality, A equals B, then I can add the exact same number to both sides, and I haven't changed anything. Golden rule of algebra: what you do to one side, you do to the other. Subtraction, same thing. If I start with an equality, then it is math legal to subtract the exact same number from both sides. Addition or subtraction are how we undo and we move addition and subtraction numbers to both sides. We keep it balanced. Multiplication and division, also partners in crime. If I start with that equality of A equals B, multiplication says I can multiply both sides by the same number, then A times C is exactly the same as B times C. And I haven't changed it because I've kept it balanced. I can divide both sides. If A equals B, then I can divide both sides by the exact same number, and I don't change my equality. So those four are our solving for X properties that we use all the time. That's how we solve for X. We add and subtract away, we multiply and divide away. Now we're just going to ask you to write that step down when you do it. The trick for some of you is one step per line. No more doing multiple steps in one. You're going to have to do every single step separately and identify what you did. Substitution, we talked briefly about that in the last video. That's our replacement, okay, property. So if A equals B and B equals C, then I can take and I can replace this B with A because they are exactly the same value. Distributive property, if A times B plus C, that quantity, then I know I can do that distributive property and I can write that AB plus AC is also the exact same thing. This one you may not have spent much time thinking about, but whenever we take the square root of something, we always have to think about how square roots work. So if x squared is equal to b, then how would I undo squaring? I would undo squaring by taking the square root, and if I do it to one side, I have to do it to the other. Then x is equal to, here's the trick, plus or minus b. Whenever you take the square root, you have to remember plus or minus. So think about that. Example, x squared is 25. Now, I know lots of you say, well, then x is 5, because 5 squared is 25. But remember, x could also be negative 5, because negative 5 squared is also 25. And that's why we always have to consider the plus and minus when we take the square root. So let's go through and do some justifying. Okay, these are our reasons. So when I start here, if 4 times x plus 8 becomes this, what property let me do that step? And the property that let me do that step is the distributive property. What math happened? What math rule did I use? In B, what math rule did I use to change x plus 9 equals 10 to x equals 1? Well, if I think about my algebra, I would subtract 9 from both sides. And so my rule is subtraction. If I look at these two statements and say, well, how did those two statements become this one? What changed? I see that a equals 6 and 3 times a plus 7. Well, what happened? That a got replaced by a 6, and that is substitution. What changed? What math rule lets me change 3y equals 9 into y equals 3? If I were solving that, I would divide both sides by 3, and so my rule that lets me do that is division. If 3x minus 20 equals negative 10 plus x, then x equals 5. Way more than one thing going on here. So let's do a little baby algebra proof. So we're going to make a t-chart. We always start with the first one. 3x minus 20 is equal to negative 10 plus x. And that's called the given. That's step 1. So a lot of times in algebra, there's more than one way to do things. So the first thing that I'm going to do is I'm going to add 20 to both sides. Now you maybe want to add 10 to both sides, or maybe you want to subtract x. You will get the same place. There is room for difference in geometric proofs. So I'm going to add 20 to both sides, and when I do that, I get 3x equals 10 plus x. And what I did was I added to both sides. And so the rule that lets me do that is addition. Now I'm solving, so I'm going to subtract x from both sides. So step 3, I'm going to have 2x is equal to 10, and that is subtracting. Now, if you want to show your work underneath, that's fine. You just have to give your reason at the step. My last step, get x alone, x equals 5, divide by 2, and I could do that step by division. That is how you do a proof. One step per line, justifying how you are moving the numbers by math rules. So this side, you're very comfortable with. This side, you know in your head, you've just never had to write it down. So you can see it's really not as scary as it's been made out to be. So let's do number 3 over here. I need a little more room. So again, let's make this cool t-chart. Step 1, we write down the if part, our given. Negative 5 times x plus 3 equals 80. And that's given. Couple different ways. You could divide by negative 5, or you could do the distributive property. I'm going to do the distributive property. Negative 5x minus 15 equals 80. And that's distributive. Now I need to move that negative 15, so I'm going to add 15 to both sides. Negative 5x equals 95. The step that let me do that was addition. I added something to both sides. Now I'm going to divide both sides by negative 5. And x is going to be negative 19. And the rule that let me do that is division. Now here, my given is that angle A and angle F are equal. So what I can write is that x plus 10 is equal to 2x minus 90. That's what my given lets me write. Now I can just solve it. So I could subtract 2x. I have to do with a negative. So I'm just going to subtract x from both sides. 10 is equal to x minus 90. That's subtraction. Add 90 to both sides. 100 equals x. Now, showing all of the work is where we're going, but that's just putting on paper what's already in your head. That's all there is to section 2, so good luck with your homework.